Okay, last segment, acid nomenclature. So an acid must have one or more hydrogen ions present in order to be considered an acid. There are two types of acids in this nomenclature category. There are binary acids and ternary acids. The binary acids have two components and the ternary acids have three. So the examples that I have here are case where you have a hydrogen present, and typically you're going to see your hydrogen right out in the front, first one into the left side of the compound. And in a binary acid, it's always going to start with the prefix hydro and end with the suffix ic. And then you have the stem name of the monatomic anion. So hydrochloric acid. So the reason that this is considered just HCl is because the hydrogen has a positive charge, the chloride ion has a negative charge, and they pair up in a 1-to-1 ratio. So something like HBr, hydrobromic acid, HI, hydroiodic acid, and HF, hydrofluoric acid. Another example that might fit into this would be something like this, H2S, and that would be considered hydrosulfuric acid. So it's not sulfuric acid, it's hydro because of the H here. And so H has a positive 1 charge, S has a negative 2 charge. That's why that formula is H2S. And so the reason that you're always going to have this hydro suffix and hydro prefix, ic suffix, is to indicate that you have a binary acid. And then the ternary acids are a little different. You have your hydrogen, of course, out in the front to the left in the formula. Hydrogen's a positive 1. And then this nitrate ion here, the NO3, is a negative 1. That's why the formula looks like this. Writing the formula is just like writing the formula for your ionic compounds. And so when you have a polyatomic ion, you're going to name according to the ending of the polyatomic ion. So this polyatomic ion is the nitrate ion. And when that pairs up with a hydrogen, it becomes the ic acid. So it becomes nitric acid. This NO2 polyatomic ion, it's different from the nitrate. It's called a nitrite. And that nitrite becomes the us acid. So the ate ion becomes the ic acid. The ite ion becomes the us acid. So that's why this one's nitric acid. This one's nitrous acid. And here's another example. It follows the same pattern. The ate ion, the sulfate ion, which is the SO4 here, that's a polyatomic ion. It's going to form the ic acids, the sulfuric acid, different from this one, which was hydrosulfuric. And then this one is the sulfate ion, that SO3. If you look on a polyatomic ion chart, it's an SO3 with a negative 2 charge. The SO4 is also a negative 2. So it's the sulfite ion that forms the sulfurous acid. And so the thing to remember here is that your binary acids have the hydro prefix and an IDE ending on the non-metal. So what I mean by that might be a little confusing. So if my non-metal is the chloride, then I know when it's forming HCl, that's going to be the hydrochloric acid. So any of the IDE ending anions are going to form the ic acid. So here's another example of that that's a little bit different. HCN. CN, although it's a polyatomic ion, it's one of the polyatomics that doesn't have oxygen in it. That is called the cyanide ion. And so I won't use, so this is, even though there's 3 components to it, it fits into the binary naming system. And so if it's in the binary naming system, then I have to call it this one would be hydrocyanic acid, because the CN -1 charge, the CN -1 charge is a cyanide. And so, sorry, I called that cyanide. It should be cyanic. So this one's hydrocyanic acid. Sorry, it's a little messy there. Okay, so ternary acids. So things to remember, ternary acids don't have hydro prefix, and the polyatomic ion becomes either an ic ending or an us ending. So here's some examples. So this ion's name is the hypochlorite ion. So if I were to form an acid with that, the acid would be called the hypochlorous ion. Don't get confused. That's just part of the name of the polyatomic ion. That's not hydro, it's hypo. And then this is the chlorite ion, and so it would form chlorous acid. This is the chlorate ion, and this would form chloric acid. And this is the perchlorate ion, and so it's going to form perchloric acid. This grouping here of this halogen with oxygen is a little bit confusing, because the name of this ion is hypo, and the name of this ion here, I put it over here, is called the perchlorate, but it's that ending that makes it the perchloric acid. Okay, so I hope my messy handwriting up here wasn't confusing. I'm just going to go back to that for a minute. So if I have this HCN, CN is a polyatomic ion, doesn't have oxygen in it, but it still follows the nomenclature for a binary acid, because the name of CN is cyanide, but when I write it as an acid, it becomes hydrocyanic. So it's because the cyanide, the name of that ion, has the IDE ending, and I completely did that wrong again. CYANIDE. Got it right. Okay, that's it. We're done with nomenclature.